my name is Bryant Myers, author of the book PEMF, The Fifth Element of Health. And in this video, I'm going to share with you some really important information about the Earth's magnetic field that you really need to know. The Earth's magnetic field is experiencing a sudden and alarmingly fast decline over the past couple centuries. And we're going to look at, in this two-part video series, the nature of the Earth's magnetic field and why it's declining and what you can do to protect yourselves. You'll also understand that the Earth's magnetic field and its geomagnetic frequencies are an essential element of health, just like food, air, water, sunshine. And I talk about this in my book, PEMF, The Fifth Element of Health. In this video, you'll understand the nature and how the Earth's magnetic field is created in a little more detail. The Earth's magnetic field, besides nourishing us, it forms a protective cocoon. This cocoon you can see in this image here of this very complex and stratified magnetic field. And you can see compared to Venus and Mars, it's much richer and much larger. In fact, Venus and Mars don't even have a magnetic field. And this protects us from radiation from the galaxy and from, say, supernova explosions and other cosmic events. And it also protects us from the solar wind and the solar flares from the sun. And what it does is the highly charged particles, the protons and electrons that shoot out from the sun, getting bent into safe orbits that will go towards the poles, which is why you see the aurora borealis. But there's a storm brewing here that is weakening our magnetic field. There's something happening with our magnetic field. If it continues to decline at the rate that it is, it might be extinct in 1,500 years. Is it possible that we could lose our magnetic field? And what would happen if we did? To better understand the nature of the magnetic field of the Earth and how it's created, let's start a little bit by talking about the Earth's core. There's a region of our planet that no human being has ever visited. It's a vast ocean of 1 billion trillion tons of molten iron with searing heat and crushing pressure. These are the conditions at the core of our Earth. Our Earth's core is buried nearly 2,000 miles beneath the surface, under 2,000 miles of solid rock. And it's partly a mystery because it's really impossible, at least with our current technology, to go there or to even take any samples that deep within the Earth. Let's look at why possibly our core is faltering right now, or why our magnetic field is declining. Peter Olson at Johns Hopkins University says that the Earth's ability to generate a magnetic field is faltering. Something very strange is going on with the Earth's magnetic field. Its strength is declining fast. So fast, in fact, according to Peter Olson at Johns Hopkins, with the current rate of decline, it'll be gone in 1,500 years. Now, this is a puzzle that's challenging scientists around the globe. To see how the Earth's magnetic field could even possibly be declining, let's look at how it's first of all created. Contrary to what you might think, the Earth is not a big spherical magnet in the center. It's not like a solid magnetic ball. In fact, it's a very molten, hot iron core, and whenever you have something that's melted and hot like that, there's going to be no magnetism. You have to have a solid magnet to do that. But because the outer core of the Earth has free electrons, the movement of those electrons around the core of the Earth, the circular movement, by Ampere's law creates a magnetic field. So the circular movement of electrons in the outer core of the Earth is going to create the magnetic field. And the magnetic field, by Faraday's law, a changing magnetic field will create a current. So this makes the Earth's core a self-sustaining dynamo, where you have the movement of electrons in the core producing the magnetic field, and the magnetic field keeping the current moving. The mechanism for how this all got started, to have a self-sustaining dynamo, something had to get it started. The theory is that this magnetic field of the sun, that pulsing field, is what got the currents going in the Earth from the sun. But without this protective force field, we would be in big trouble. And again, you can look at Mars, and we'll talk about that in a minute, and how it's a dead planet now. So the dynamo theory was first proposed by Albert Einstein and others. And as I just explained, it's this self-sustaining, very dynamic production of the Earth's magnetic field. I just want to emphasize that because a lot of people just tend to think of the Earth like some big bar magnet, and that's just not true. Now let's talk about the solar wind. The Earth lives in a highly energetic environment with intense radiation and charged particles bombarding it all the time. Now, space weather is nasty. The winds that blow through the galaxy are winds of intensely high frequency and radiation, both gamma and cosmic rays. Some of the most harmful cosmic rays are from distant exploding stars. But much nearer is our sun, which is a nuclear thermal furnace, and it flings off very dangerous material in very, very large explosions. Every few hours, the sun's injecting billions of tons of electrically charged particles, and this solar wind, as it's called, from these charged particles, bombarding the Earth. In fact, the Earth lies directly in the path of this onslaught. But, as I explained earlier, the Earth's magnetic field deflects these charged particles, and the Earth's atmosphere filters out most of the harmful radiation. This means the solar wind is unable to really penetrate the Earth's magnetic field. So like a well-built house or a bunker that shields you from weather, even hurricanes, the Earth's magnetic field protects us from the sun's solar winds and other space weather. In fact, the northern lights, or the aurora borealis, is evidence of the Earth's magnetic field bending these charged particles into safe orbits. The magnetic field lines are deflecting those charged particles to the north and south pole. But what are the consequences of having no magnetic field? As we talked about, the magnetic field of the Earth is declining. Well, let's look at Mars. Hidden in the mystery of Mars lays the connection between magnetism and life. There's evidence that Mars was once a living planet with water and perhaps even complex life. In 1996, NASA sent a satellite to Mars to test the magnetic field and other variables. Does Mars have a magnetic field? What NASA found was that the Mars surveyor sent back data confirming that Mars has no magnetic field currently. But interestingly, large areas of the surface were magnetic. There was a time that Mars was very volcanic. If a strong magnetic field is present, volcanic molten rock can cool and become magnetic from iron-based minerals. Magnetism in the Martian crust proves that it must have once had a magnetic field, and it must have also lost it. In fact, NASA found that the Martian magnetic field was probably once about 20 to 30 times the intensity of the Earth's magnetic field. A young Mars may have been Earth-like with water and teeming with life, but according to NASA measurements, 4 billion years ago there was a catastrophic decline. The Martian oceans and atmosphere disappeared. But without its magnetic field, the solar wind had direct access, and like erosion in a desert, the water and atmosphere were blown away, leaving the sterile red planet we see today. If the Earth's magnetic field disappeared, the same thing would happen. The Earth would experience the erosional effects of solar wind over time, and the Earth could become a dead planet. Let's take a look at this history of our Earth's magnetic field, and we'll begin by looking at an unlikely source of understanding the Earth's magnetic field, which is pottery, believe it or not. John Shaw of the University of Liverpool found a very interesting connection between pottery and measuring the magnetic field of the Earth. Pottery acts like a magnetic tape recorder, recording the Earth's magnetic field strength at the time it is made. Pottery is like a miniature magnetic time capsule. So if we take an ancient pot, like sort of the one shown in this image, which was perhaps made in some ancient civilization, when it was cooled for the first time, it cooled in the Earth's ancient magnetic field and became magnetized in that field. And of course, if the magnetic field is very strong, then the pot is going to be more strongly magnetized. And if the field's weak, then the pot's going to be more weakly magnetized. The pot itself becomes slightly magnetic. When we plot the results from the ceramics, this is what we see. Gentle changes have come forward in time over 12,000 years. A gentle rise and a rapid fall as we come towards the present day. The rate of change is higher over the last 300 years than it has been for any time in the past 5,000. It's going from a strong field down to a weak field, and it's doing so very quickly. So magnetite in the clay, when the pot is heated, new magnetic regions form, just like little compass needles. So John Shaw at the University of Liverpool, he found a way to extract precise measurements of the Earth's magnetic field at the time the pottery was made. In the next video, part 2 of this series, we'll look at why it is the magnetic field of the Earth is declining and what you can do to protect yourself during this decline. In the second video, we're going to look at actually why the Earth's magnetic field is currently declining and what you can do to protect yourself. So let's continue where we left off in the last video. We were talking about how pottery acts like a time capsule, which has shown that our Earth's magnetic field has been rapidly declining over the past 300 years compared to the past 5,000 years of that research. We're going to start this video with a May 1988 issue of Scientific America magazine, which detailed today's ongoing degrading of the Earth's once powerful magnetic field, which is now measured at about 50% of its intensity that it was several centuries ago. Scientists calculated if this degradation continues, there will not be a sufficient magnetic field to support life within 1,500 years. So the last 300 years it has fallen the most. In the article, it even mentioned that the Royal Navy also has detailed logbooks of the Earth's magnetic field over the last 300 years, and it further confirms that it's now an almost proven fact that our Earth's magnetic field has definitely been declining. So there's much evidence from many different areas of research and even the British Navy. So we know that the magnetic field of the Earth is declining, but the question is why? Possibility number one is that maybe the Earth's core is cooling. Let's take a look at that possibility. Moving liquid is critical to the outer core for the electrons to move around. And if the core cooled, then the dynamo would slow down. This inner dynamo that's creating the magnetic field of the Earth would slow down. Mars is a much smaller planet and it's colder, so it cooled off quicker. And that's how actually Mars' magnetic field did become extinct, is that the core cooled, the currents failed to continue to circulate, and the magnetic field disappeared. Will what happened to Mars happen to the Earth? The Earth's core is also cooling, but the Earth is much bigger, the core is much hotter, and, we're closer to the sun. But the core is declining, but only at about 100 degrees per billion years. So this means that we have a core that will continue to burn for several billion years into the future. At least, by some experts, at least 2 billion years we're safe. So that is not the reason that our Earth's magnetic field is declining, because our current rate of decline is much, much faster than these models of the Earth cooling could possibly predict. So if it's not the Earth's core cooling, what else could it possibly be? The first evidence to explain the decline was actually found in the volcanoes of Hawaii. The volcanic islands of Hawaii, when there's a volcanic eruption and the lava descends down and cools into the Pacific Ocean, just like the clay, when we talked about the clay pottery, the lava will cool. And because of the iron deposits in the lava, those deposits become magnetized, both in the intensity that's related to the intensity of the Earth, but also the direction of the magnetic field. And you can see millions of years sort of worth of history of the Earth's magnetic field, because as you dig deeper through the lava, you can go backwards in time and really see the magnetic field and how it's changed over the past millions of years. And what we find is something very interesting, is that the magnetic field of the Earth actually switches polarity on average every 300,000 years or so. What this evidence also found was that there has not been a pole reversal in about 780,000 years. So we're actually much, much overdue. Again, this evidence goes backwards in time. When we talk about a pole reversal, we're not talking about the actual physical Earth flipping upside down. That's a pole shift. Sometimes people use the terminology incorrectly. A pole reversal is when the magnetic north and south switch polarity. And our sun actually switches magnetic polarity every 12 years or so, almost like clockwork. But the Earth is a much slower and more chaotic. It's not as regular based on the evidence. And there's further evidence to support this on the ocean floor. Because through plate tectonics, we know the Earth's plates do in continental drift. We know that they move and shift. And in certain areas where the plates are moving apart from each other, you have like matter from the Earth's core, just like a volcano, there's little outlets from the Earth's core to the ocean floor as well. And those find their way to the ocean floor and they'll cool and also become polarized to the current magnetic field of the Earth in both the direction and the intensity, just like the lava cooling in the ocean around Hawaii. And there's been evidence in many other areas around the world where scientists have seen this pole reversal on average every 300,000 years. And again, it's been about 780,000 years since the last pole reversal. The next very interesting piece of evidence comes from computer simulations. And these computer simulations actually further explain why an impending pole reversal would actually cause the magnetic field to be weaker as it's approaching. NASA did some computer simulations using a model of Glatzmeyer and Roberts, and their findings were published in Nature magazine. And it's very, very fascinating And you can see from the images here, I'm going to show you a little animation. The tubes represent the magnetic field lines. The blue when the field points towards the center. The yellow is when it points away. So you can kind of follow those field lines. And the dense clusters of lines are within the north and south because that's where the field is the strongest. So these computer simulations involve dozens of equations that were solved using supercomputers over 4 years to see how the magnetic field of the Earth would evolve. What they found was that it did reverse polarity every 100,000 years or so. And when it reversed, the magnetic field always became weaker before the reversal and during the reversal. So reversals are always heralded by a weakening magnetic field. And they also start with magnetic anomalies, which are patches where the field lines are going in the wrong direction. You can see from this image that the normal flow of the magnetic field on the Earth is where the field lines go out the South Pole and then into the North Pole. But what's happening right now is there's a South Atlantic anomaly. And the South Atlantic anomaly is showing fields that are going in the wrong direction. Where they should be going out, they're going in. And you can see this in this image here, that big red spot, that big red patch is where the field's going in the wrong direction. And just like you have water moving in one direction, if you counter that with water flowing in the opposite direction, you're going to slow down and weaken the stream. And that's exactly what's happening. One of the explanations why our magnetic field is declining right now. So we're definitely long overdue for a pole reversal, and there's certainly evidence that it's happening, not only with the South Atlantic anomaly, but the wandering of the North and South poles. They're just, moving around more and more every year. So what would happen during a pole reversal? The good news is that from an aesthetic point of view, there'd be more auroras, the aurora borealis. If you've ever had the pleasure of seeing that, which I have myself, it's incredibly breathtakingly beautiful. But the bad news is that there'd be more cosmic radiation at the ground level, and we would be getting less and less magnetic field. Even though the magnetic field's weak right now, it'll continue to get weaker as the poles reversed. And this kind of then ties into what's called magnetic deficiency syndrome, which is a condition resulting from insufficient Earth's magnetic fields. So magnetic deficiency syndrome, there was a paper published in 1976 in Japan Medical Journal by Dr. Kiyoshi Nakagawa, and he's one of the world's top authorities on magnetism and its therapeutic effects on the human body. He claims that the Earth's degrading magnetic field combined with mankind's electronic environment is responsible for this magnetic field deficiency syndrome. Dr. Nakagawa found symptoms such as chronic pain and sleep disorders became magnified when the body tests too low for the Earth's pulsating magnetic fields. Japanese industrial workers who spend long hours inside metal buildings that block our Earth's natural magnetic field began to show the following symptoms based on Dr. Nakagawa's research. This is what he looked at, is these industrial workers that were basically shielded from the Earth's natural magnetic field. He noticed insomnia, decreased energy, dull aches, and general body pains. And the installation of artificial magnetic fields alleviated these symptoms. So magnetic field therapy and pulse magnetic therapy is the cure for magnetic field deficiency syndrome, which of course makes perfect sense. With the decline of the Earth's magnetic field and an impending pole reversal, investing in an Earth-based PEMF device may not only be wise, but an essential survival tool because the Earth's natural PEMFs is an essential element, as I explain in detail in my book, PEMF, The Fifth Element of Health. With 7 years' experience helping thousands of people, I can confidently say to you that you will notice more energy, better sleep, and less pain almost immediately using a PEMF therapy device, especially a device that's inspired by the Earth's natural intensities and frequencies.